Okay, let's keep going with the next problem. We have Maria, and she's starting a small DVD business online. She makes $2.25 on each DVD she sells. That's important. Let's underline that. To start her business, though, she has to invest $750. So maybe that's to buy all her inventory for her DVDs she's going to sell. How many DVDs does she need to sell before she starts to make a profit? So do you guys know what profit means? Okay, so profit means after you spend all the money on your supplies and you sell some until you start making money, because you're not making money until you pay off all your startup costs, your overhead. So let's talk about our unknown here. X equals what? What is the question asking us for? Number of DVDs sold. So we want to know how many DVDs do we need to sell until we make a profit. So we need to make more money than how much we invested. Well, we invested, or she invested, $750. So what are we making money on if this is what we spent to start our company? Oh, we're making money on each DVD we sell. We make $2.25. So if we make $2.25 on each CD and we sell X CDs, we're making a total of $2.25 times X. And we want to know when this number is greater than that number. If it's equal to, we're not making any profit yet. We're just breaking even. We're not making any money. So we want to know when this number is bigger. So let's take a look. If I want to isolate my variable, I'm going to divide both sides by 2.25. Go ahead, use your calculator. 750 divided by 2.25. Ooh, gee, kind of a long repeating decimal. I got 333.33333 repeating. 0.3 repeating is same thing as 1/3. So 333 and 1/3. Well, let's go back to what the question's asking us. How many DVDs does she need to sell? Can you sell 1/3 of a DVD? So if I sell 333 DVDs, will we be making a profit yet? No. So Maria needs to sell at least how many DVDs? 334 DVDs to make profit, to make any profit. Make some money. Or you could say more than 333, but we like the at least 334. Awesome. Let's move on to the next problem. For 5, I want to make an edit to the word problem. It says the community swimming pool charges a flat rate of $50 for a birthday party plus $2.50 for each person. Change that word person to guest because the birthday girl, Deborah, she's free. So the birthday kid is free. Awesome. So let's read this one more time. The community swimming pool charges a flat rate of $50 for a birthday party plus $2.50 for each guest. Deborah can't spend more than $100. How many friends can she invite? So what's our unknown? X is the number of friends invited, or number of guests. And I'm going to give you 8 minutes, and I'd like you to finish 5 and 6 with your group. Go ahead, please pause the video for 8 minutes and finish number 5 and 6 with your group. Okay, let's see how we did. So on number 5, X is the number of friends invited. We have that $50 flat rate, so we have 50 plus $2.50 per kid, so 50 plus 2.5 or 2.50 times X has to be less than or equal to 100 because she can spend 100 but she can't spend more than 100. So this amount has to be less than or equal to 100. To isolate my variable, I subtracted 50 on both sides. From there, I needed to divide both sides by 2.5 or 2.5. And when I do that, I got x has to be less than or equal to 20. So when it asks how many friends can she invite, is it at most 20, at least 20, a maximum of 20? Well, Deb can invite a maximum of 20 friends, or we could say at most 20 friends is another way. But we have to invite 20 friends or less is another way we can say it. Let's see how we did on number 6. On number 6, the unknown here is the number of minutes because we want to know the most number of minutes that Jacques can purchase. So taking a look here, since we're charged 40 cents for every minute and we have $45 to spend, we can spend exactly or equal to $45, but we can't spend more than. So we have this amount is less than or equal to 45. To get x by itself, I divided both sides by 0.4, and I got x has to be less than or equal to 112.5. So thinking about a phone company, they're not going to sell us a half a minute. They're just going to charge us. Even if we don't use that whole minute, they're going to round up. So what is the most minutes he can buy? The most minutes he can buy is at most 112 minutes. Because at 112.5, we spent $45, but at 113, it's too much. We don't have enough money. Great job. Let's go on to our last page. Okay, number 7, I'll help you get started on this one. Harry wants to download some songs to his iPod player. If he gets a $20 gift card for his birthday and each song costs 90 cents, at most, how many songs can he download? So what's our unknown here? They're asking us about the number of songs he can download. So x equals number of songs downloaded. Remember, we want to be very specific when we define our variables. So let's talk about the inequality here. So we have $20. Could we spend exactly $20? Yes, we know it could be or equal to. Could this amount be greater than $20? No. Could this amount be less than $20? Yes, it can. We don't have to spend the entire gift card. Maybe we're waiting for a new CD to come out. So let's talk about how we're getting charged. We're getting charged 90 cents per song. And if we bought X songs, we spent how much money on songs? 90 cents per song, so 0.90 times X. Excellent. Let's keep solving. To isolate my variable, I'm going to divide both sides by 0.90. Go ahead and grab your calculator. 20 divided by 0.9 or 0.90, and what do you get? Did you get something like 22.2 repeating? Can you download a part of a song? Are they going to let me do that? Just 0.2 of a song? No, they're not going to let me do that. So remember, if we downloaded 23, we don't have enough. If we think about x has to be less than or equal to 22.2, well, 22 is less than or equal to 22.2. Repeating. So we can say Harry can download up to 22 songs, or a maximum of 22 songs, at most 22 songs. Those are different ways you can say that. You can say at most 22 songs, a maximum of 22 songs. Okay, last problem. Let's take a look at our last problem. You have $10 to spend at the school carnival. No more, but you can spend less or equal to. If each game costs 25 cents, how many games can you play? Please pause the video for 3 minutes to finish the word problem. Thank you for pausing the video for 3 minutes. Okay, let's see how we did. Since it asked how many games can you play, our unknown is number of games played. We only have $10 to spend and each game's 25 cents. So we're going to spend 0.25x at the carnival. We can spend less than or equal to $10. So this amount needs to be less than or equal to $10. To isolate my variable, I divided both sides by 0.25, and I got x to be less than or equal to 40. That means I could play 20 games, 35 games, 39 games, 40 games, so I can play at most 40 games, or a maximum of 40 games, or 40 games or less. There's a lot of ways you can say that. Excellent job. You are done with this lesson. There's no reflection for this lesson. We're going to take the rest of the class period to be working on homework quietly together. Have a great rest of your day. Do your best and be nice to everyone. Thank you.